before we get started, are there any questions over any of the assignments so far? Feel comfortable with most of the assignments so far? All right. What we're looking at today is graphs of sine and cosine functions. Now with these graphs, you're not going to be asked to actually have to graph them, but we're looking for key points, key piece of information that we can obtain from each one. Now to sketch a graph, if we were actually going to sketch the graph of sine and cosine function by hand, it helps to note 5 key points. And those key points are 1, the intercepts, where it intercepts the x-axis, the maximum and minimum points, these key points here, and they have the same for sine and cosine. The first one's going to be, if we look at this here, 0 degrees would be cosine, and the other one is sine. And if we know these 5 points, especially from 0 to 2 pi, 1 period, we can actually be able to graph the rest of it. Because for sine or cosine functions, they repeat themselves, so if we know one interval, one complete interval, we can find the rest. Well, now there's several key characteristics. I have this listed down in your note sheet, and I also have it listed a little bit below it. Now the A part of both of these here are going to tell us one of 2 things. The amplitude, which will be, the amplitude is equal to the absolute value of A, whatever it is. And we do have that on the next slide. The amplitude of y equals a sine of x or cosine, respectively, represents half the distance between the maximum and minimum value of the function, how high or low it's going. Now it also can tell us if there's a reflection across the x-axis. Now there's a reflection across the x-axis only if A is negative. If we have a negative A, a negative sign in front of sine or cosine, then it's going to be a reflection across the x-axis. Any other value is going to tell us the amplitude. Same thing's true with cosine. The B value is where we're going to get our period from. In the period of sine and cosine function, let B be a positive real number, such that the period for these here is given by 2 pi over B. So if we want to know the exact value of the period, it's going to be 2 pi over whatever this B value is. Now the H value, well, we actually are going to say H over B. In the general form case, and what they tell us here, they call it C, is going to be the phase shift. So in the notation I have here, B over H, or they have it C over B, is going to be the phase shift, how much it moves the function to the left or to the right. And we'll just say whatever that value is going to be the phase shift. We can specify left or right depending on the sign. If H over B is positive, it moves to the right. If H over B is negative, it moves to the left. And that's really all dependent on what the sign is. I want to look at one thing because I don't like how those equations are represented. I think I need to change them. Yes. I knew I didn't like it. That color. Oh, that's fine. Both of those need to be minus. And it's more coming from the fact that that's kind of part of the function notation itself is doing that there. It's minus h, it's minus this value. I think it's one of those things I probably, if I went back and listened to the video from last year, I probably did the same adjustment on those and then forgot to change it. There's a lot of the lesson slides that's how it worked out, especially with first chapter, which technically would be chapter P for this one here. But we have this here. Now, this may seem odd, I just plugged that in or realized that, but that comes from most of our notation. Now, this is above and beyond, because the general form for our quadratic equation in vertex form is this here, in the parentheses x minus h. If we look at the equation of a circle, is this here. And if you notice inside both parentheses, it's x minus h, y minus k. If we look at an ellipse, is this here, a hyperbola. If you notice, there's a commonality between all of them, especially when we have parentheses, this sign between h and k or whatever we have that shift left and right is always minus. That's part of the reason I realized that was off. That should not be the case, is because all of them, when we have those parentheses, it's minus. So that means if we're talking about shift left and right, it's going to seem opposite of what we think it is. So if it's minus h, we're actually moving to the right. If it's plus h, we're technically moving to the left, because for it to change from a minus to a plus, the h value actually has to be negative. It's kind of, we have that opposite shift, if that makes sense. Now, it seems odd that we have it noted as h over b. And the reason for that is because when we actually look at it, we have to factor out that period, that value of b from it. To really get our true value for this here. From whatever that amount is. And lastly, k is a vertical shift. It's just going to tell us how far it moves up or down. Zoom. Sine function. Now, the only one we didn't really specify is if we have a negative inside the parentheses in front of x. And all that's going to be is a reflection across the y-axis. It's going to flip it across the y-axis, flip it that direction. Because we'll get almost the same function, just reflected across the y-axis. Now, negative sine of x is going to flip it across the x-axis, which in our case is going to look the exact same. And we can look at cosine. reflected across the x-axis. I have a feeling. Now, negative inside of the parentheses is reflecting it across the y-axis. And there's actually a reason for this, because I wasn't planning on talking about this. Cosine of negative x equals cosine of x. We've actually had this. This is one of our identities. We said because cosine's an even function that this is true, and this is just because it is even. Sine of negative x equals negative sine of x is true because it's an odd function. Now I do have these listed for y'all here, so you do have them. The amplitude, the period, our phase shift. And the reason that these are helpful, especially with graphing, is that if I know the maximum and intercepts, the phase shift's how far it's going to move left or right. So if I know that, I can take for sine all of these points here and move them left or right, their corresponding amount. The period will let me know 0 to 2 pi, how is it going to change? I can determine all these pieces of information based off of what it's given me. So if we look at this here, now, looking at this here, there's several different parts. Is there a value in front of sine, our a? I mean, there is one, it's just 1. So the amplitude for this is 1. We'll always have an amplitude, it just might be that the amplitude is 1, it's just not a number other than that. Reflection, well, none, because the value of a is positive. The other spot where we could have a reflection is where b is at, and it is positive as well, so there is no reflection. Phase shift. Well, phase shift comes from our h. Well, there's not an h value there, so that is also none. Now, I avoid this on the tests and review sheets, but if instead of just a decimal point they put +2, this here, that +2 is not inside the sine function. Does that make sense? So they do this in a lot of notation, they just don't put parentheses around sine, expecting you to understand that the +2 is actually outside the function. It's not this here. It's actually this here if we wrote the parentheses in. I will avoid doing that. I will actually put the parentheses around it even if they're not necessarily needed, so we know for sure. But that also tells us that the vertical shift for this is none. There is no reflection, there is no phase shift, there is no vertical shift. But there is a period. Just like amplitude, there will always be a period, even if it's just 2 pi. But we need to figure out what the value of b is. Now, this is the same as saying sine of 1/2 x. So it's telling us the value of b is 1/2. Now to find our period, well, the definition of the period is 2 pi over b. So what we're saying is that I have 2 pi over the value of b, which is 1/2. Now we could do this in a calculator, we could do it by hand, either way works. 2 pi over 1/2 is 4 pi. So the period is 4 pi. Amplitude is 1. There is no reflection, there is no phase shift, there is no vertical shift. So you don't have to put this down. 1, -1. Now what we're saying is that the new period is from 0 to 4 pi. Because our original sine function started at 0, 0, at 2 pi was still back at 0. At the halfway point, which normally would be pi, it would be back at 0, but for us here, it's now at 2 pi. Which should mean at pi and 3 pi, it's going to be at 1 and -1. Well, almost. We kind of get this here. It's not sped out correctly, but that would be the function we get. It's actually taking it twice as long to do one full cycle. Now, y equals, clear both of those out. So our normal sine of x, we'll put it in first. And then we can say sine of 0.5x, 1/2 x, graph. So we can see already for it to do one full cycle from 0 to where pi is at, the one in blue does one full period, goes through one full cycle, but the one in red only goes through half. We only have the upper half. So it does take it longer to go through one. But that's it. Questions on this here? Okay. Now looking at this here, there are several different things we need to get into because different places. The one thing we know for sure is our plus k, we don't have anything added to the end. So there is not a vertical shift. It's not moving the function up or down. But our amplitude for this, our value of a is -3, or we can say a is -3. The amplitude is the absolute value of a, which would be 3. So the amplitude for this is 3. Questions on this here? So it asks for reflection. This time we do have y equals -3. So we can say, yes, there's one across the x-axis. There's not one across the y-axis because the value of b is positive, so we don't have a reflection across the y-axis, but we do have one across the x-axis. Now, phase shift and period, the one that we can actually do first is our period, because our value of b in this case is 2 pi. And to find the period, we take 2 pi and divide it by the value b, which is 2 pi, telling us the period for this is 1. Now there's two ways we can go about getting the phase shift, our last bit. One of them is we can rewrite this equation. And factor out the 2 pi from both terms. And if we factor it out from x, 2 pi x, we just have x plus. If we factor the 2 pi out of 4 pi, we're dividing it. So I could use a calculator and say 4 pi over 2 pi, giving us 2. If we factor it out, we got plus 2. It would tell us our phase shift is 2 units to the left. Since it's plus on the inside, it should be minus. It's moving to the left. The other way we could have done this is our calculate h over b. Well, the h value is 4 pi over 2 pi, leaving us with 2. We know it should be negative, so it's moving left 2. Cosine of 2 pi x plus 4 pi we get this here. We do know that it's going to be increasing or repeat itself a lot faster because we said that period is 1. So for every 1 unit, cosine will have 1 full period. Now they're not going to match up evenly. It kind of looks like they do. Yeah. No reason to keep doing that. But it will get close because 2 pi, for it to repeat itself for cosine, is 6.28 going on. And it looks like they might have the similar value. But at that point, the other one's repeated itself 6 times because every one it will repeat. Well, we get this here, and that's a little bit harder to graph because it is repeating itself so fast. Questions on any of this here? We ready for the next one? Let's look at this one here. Is there any of these that we do not have one of? Do we have a vertical shift? No. Do we have a phase shift? Do we have something because a sine of b x minus h plus k, do we have a value in the h spot inside that parenthesis? Because k is up and down, our h, no. So phase shift is none. How about a reflection? Do we have a negative in front of sine or in front of the x inside of sine? No, so there is none. So that leaves us with amplitude and period. There will always be an amplitude, there will always be a period. Now the amplitude is our absolute value of A, which would be the absolute value of 2/3, which is, right, or we can just say 2/3. So the amplitude for this is just 2/3. Well, it'd be good if I actually wrote that on the line for amplitude and not period. Now for the period, we do need the value of b. Well, the value of b is. And to find the period, we take 2 pi over the value of b. Even if there's not a number written there other than 1, the period is understood to be 2 pi, because we can still calculate it. 2 pi over 1 is just 2 pi. So the period for this is 2 pi. The amplitude is 2/3, and that's it. Everything else stays the same. It's just that the maximum and minimum values for this sine function are going to be 2/3 of what they normally should be. It's just lower down. And that's it. Questions on this here? So we know there's always going to be a period, there's always an amplitude. Is there a reflection? No, none. Is there a phase shift? No, there's nothing added to x inside the parentheses or subtracted from it. Is there a vertical shift? No. There's nothing added outside or added to sine there. Now the amplitude, well, our a value is 4. Absolute value of a is still 4. And the period, well, our value of b is pi. So to find the period, we take 2 pi over the value of b, which is pi, which tells us that it is 2. So the period in this case is 2. Questions on this here? And again, this is one of the cases they didn't directly say it, but the 1/2 x is inside the parentheses, the -4 is outside. Now this time, do we have a vertical shift? Well, the -4, yes. It's telling us that it's moving 4 units down. Moving it down 4. Now the phase shift left and right, there's nothing added or subtracted inside the parentheses, so this would be none. The sign in front of sine is positive. The sign in front of x inside of sine is positive, so there is not a reflection. Almost, because amplitude is our a, and the a in this case is 1. Now there is a 1/2, but it's not associated with a, it's actually associated with b. And that's a part of our period, because we're saying 2 pi over b, or 2 pi over 1/2, which is 4 pi. And that's it. Questions on this here? We're ready for the next one. Y equals sine of x minus pi over 4. There's no reflection, none. What else can we say? Is there a vertical shift? No, so we can say none. Now there is a phase shift. Well, we do have the pi over 4, yes? Well, what's our value of b? 1. So the phase shift would be whatever that value is divided by b, which is just pi over 4 divided by 1, which would just leave us with pi over 4, and we would move to the pi over 4 right. Amplitude. Well, the value of A, the value in front of sine is 1, so the amplitude is 1. Period would be our 2 pi over B, which is just 2 pi. And that's it. Questions on any of those here? Yeah, we're almost done. Is there a vertical shift for this here? No, there's nothing added to the end, so there's not a vertical shift. Now we do have a phase shift, because we have that minus 3 pi over 2. What's the value of B? 1. So the phase shift is going to stay 3 pi over 2, and it's going to go to the right. It's going to be the opposite of what we think. Really right and left, because they are cyclic functions, cyclic in nature. They actually move the same value left and right for the most part. But 3 pi over 2, right. Is there a reflection? We look in front of the 4, or where the 4 is at in front of x. Both are positive, so there is none. Amplitude. The value in front of sine, which is 4. So the amplitude for this would be 4. And the period, well, that takes in the B value, which is 1. We'll say 2 pi over 1, which is just 2 pi. And that's it. Questions on this here? Y equals 3 sine of x plus pi minus 2. Well, the minus 2 tells us we have a vertical shift of what? Down 2, 2 down. Either way works. Now we do have plus pi on the inside, but the value of B is, so we would say pi units. Since it's plus, it's actually to the, so we're moving it, have a phase shift of left pi. I think most would just say the phase shift is pi. Now the two places that we could have a reflection where there needs to be a negative are actually both positive, so there is none on their reflection. What would our amplitude be? 3. And what would the period be? 2 pi, because since the value of B is 1, it tells us that the period is 2 pi. That's it.